Hello everyone, my name is Ch01. I'm so happy to introduce my new course, Docker Fundamental course. In this video, I will explain Introduction to Docker as a Chapter 1. Main topics in this video I will focus on to explain this kind of topics. First will be Docker concept. Second will be the difference between virtual machine and Docker, and Docker architecture, and the last topic will be Docker components. Terminologies to understand. It means that before we study Docker, we have to understand some terminologies which has a relationship with Docker. So first will be cloud computing. Second, virtualization. And the virtual machine, last terminology will be hypervisor. Cloud computing. Cloud computing means it's a kind of technology to provide reading, writing data and storing and managing them over the internet. To do this kind of function of the data, normally we can use some of the devices like a smartphone, computer, and a laptop. Using this kind of devices, we can connect the internet, especially in the cloud. So, what is the cloud? Cloud means space is used for data storage. If we use this kind of cloud computing, then we can access our data in the cloud anywhere and anytime. When we suggest this kind of cloud computing, there are three cloud computing models: SaaS, PaaS, and IaaS. Especially an IaaS, infrastructure as a service, I can suggest some of the programs like OpenStack, CloudStack, OpenNebula, and Eucalyptus. So this is cloud service model three types: SaaS, PaaS, and IaaS. In case of the end users focusing on the SaaS means it's a package the software. But application developers can focus on the PaaS. PaaS means the platforms like operating system and application stacks. And the infrastructures and the network architectures can focus on this one: server, storage, networks, Azure, IaaS. I mean the infrastructure as a service. So the past terminology is virtualization. So virtualization is one of the technologies to implement cloud computing. If we want to use cloud computing, then there are so many technologies like virtualization. So virtualization, if we use in especially cloud computing, this one means is an act of the creating virtual version of computer resources. So what is the computer resource, such as CPU, operating systems, storage, and computer network resources? In virtualization, there are three types: the full virtualization, part virtualization, and partial virtualizations. Virtual machine is an emulation of particular computer system. It's a resource. Virtual machine also computer systems having the resources such as CPU, RAM, and disk space, like a personal computer. Each virtual machine has its own kernel, operating system, and supporting libraries or binaries. This virtual machine acts like a real machine, like a personal computer and physical computer, but this is not a real machine, just everything is virtualized. Hypervisor. Hypervisor is a logical platform to create and run multi-operating systems at the same time on one host computer. So here we have to focus on the two words. Operating system is a virtual machine and host computer. So if we want to use hypervisor, there are two components like virtual machine and computer. For example, here, hardware and hypervisors like Hyper-V, Gen, and then here we can use the guest operating system. Guest operating system means it's a virtual machine. So in hypervisors, there are many kinds of the softwares like Gen, KPM, VMware ESX, and Hyper-V. Hypervisors, there are two types, type 1 and type 2. In case type 1 hardware, then we can install this kind of hypervisor programs on hardware. Based on this hypervisor, we can create many operating systems. So here, operating system is a virtual machine. Type 2, normally we call hosted hypervisors. So hardware is the same, but in this case, we need to install operating system. Normally we call this the host operating system. And then the hypervisors will be installed on this operating system. Using this hypervisor, also we can create many operating systems as a virtual machine and guest operating system. The topic of this video is Docker. So what is Docker? Docker is container platform provided to address every application across the hybrid cloud. So here you can find the cloud. It means that Docker also is a kind of the platform which can be used in cloud system as well. Docker is containerization technologies to provide abstraction of operating system level virtualization. So here virtualization. So Docker also related to virtualization as well to provide operating system. Docker is a tool designed to make it easier to create, deploy, and run applications by using container. If we use this kind of container, we can use many applications. User's focus is to use these applications. And then we need two container provided by Docker. Docker is an open source application deployment container that evolved from the Linux containers used for the past decade. It means that Docker is one of the Linux containers. So this kind of Linux containers allow different applications to share operating system, kernel, CPU, and the RAM as well. So Docker is based on these Linux containers. Who is Docker for? Docker can provide the main three features. First, build applications and ship applications, then run these applications. Especially this kind of build can be operated by application developers, and these developers can ship this built application ship. And after that, these shipped applications can be run by operators or managers or IT operators to deploy, manage, and scale out. So what is container? In previous page, I already explained the meaning of the Docker. So Docker is a technology to use the container. So what is the container? Container allows the developer to package up the application with all of the parts it needs, such as library, other dependencies, and ship it all out as one package. So container can contain many libraries and dependencies and binaries or kernel like this, and after that can create this one package. Container focus on application layers. These applications, normally the packages, code and dependencies. Code and dependencies like binary and kernel like this. Multiple containers can run on the same machine and share the operating system kernel with other containers. Each containers can be running as isolated processes in user space. If we have one operating system, then we can run many containers, and these containers will be isolated process in user space, not kernel space. So this is an example here, Docker containers. So Docker container will contain applications, binaries, libraries on Docker. So the other containers using on host operating system. This is a kind of the example of Docker container. So here, for example, as a base image, Debian, and the other images like Java and Tomcat. then this one will create one container. Also, this one will create the other containers and the other containers. And these all containers will share the same kernel on one host operating system. So let's compare between virtual machine and Docker container. As you see, in case of the virtual machine have the hypervisors, host operating system, and infrastructure. And after that, they need the guest operating system. Using this guest operating system, they can use the applications based on binaries and the libraries. Each virtual machine has this kind of the structures. Let's check the Docker containers. So infrastructure same, operating system is the same, but there is no hypervisor. But instead of hypervisor, there is a Docker engine. Using this Docker engine, we can create these containers, and containers. Each containers doesn't have their guest operating system. Even if there is no guest operating system in containers, we can use these applications without any issue and problem. This is the difference between virtual machine and Docker container. Also, there are more difference between virtual machine and Docker container. Let's check size. In case of the virtual machine, their size are a bit heavy, but Docker is lightweight. Startup virtual machine are a bit slow, like a tortoise here, but Docker container is very quick to start their service, like a cheetah. Integrations. Virtual machine are a bit complicated to integrate with the other programs, but the Docker no problem to integrate with the other programs. So this is a summary of the difference between virtual machine and Docker containers. So virtual machine focus on physical hardwares, but container focus on application layers. And these applications will package code and dependencies together. Each virtual machine runs its own operating system. We normally call this one guest operating system, but containers just share the host operating system. Virtual machine need the hypervisors and the full operating system inside, but containers just talk host kernel. Startup this one is slow, but this one is very fast. The virtual machine run multiple virtual machines on one machine. Containers just run many Docker containers on one machine as well. The virtual machine is fully isolated and hence more secure. However, containers process level is isolated, so hence less secure. Virtual machine need more spaces than containers like a RAM and hard disk. Virtual machine complicated to integrate with other programs like Puppet, Ansible, Git, Nagios, and etc. However, containers is very easy to integrate with the other programs and scale up using containers. Now, let's go too deep to know Dockers. So Docker internals, so Docker engine, Docker architecture, and Docker components. The last will be Docker tools. Let's check Docker engine. Docker engine has the three components. First, Docker server. Second, REST API, and the third is a Docker client. Docker client want to connect the server through this REST API, and after that, Docker client can manage many Docker components like a container, image, data volumes, and network as well. So here, Docker engine is a client-server applications including first server. And the Docker server always will run the Docker daemon process. The daemon process name is Docker D. Second is the REST API. This one is a kind of the interfaces. The programs can use the top daemon in the server side and instruct it what to do by Docker client. And the command line interface is normally Docker client use this one. So whenever Docker client uses the server side, then normally we use the command Docker to check the Docker architecture as well. So I already in the previous page, explained Docker engine, and Docker has three components like Docker client, Docker daemon, and REST API to connect between Docker client and Docker daemon. So in Docker architecture, also there are three main sources: Docker client, Docker host, and the registry. In case of Docker client, can use this kind of command: Docker build, pull, and run. This kind of command will be transferred to Docker host, especially Docker daemons. Docker daemon will connect like containers and images. If client want to use this kind of images or containers, then they need to access this kind of Docker registry in Docker website. So if we check this line here, Docker build means Docker creates images through the Docker daemon, and the Docker images will be saved in Docker host. And using Docker host, we can start these Docker containers. If client want to download some image from Docker registry here, and this Docker image will be saved in Docker host as well. Also, Docker client can upload this image to Docker registry as well. Docker has the client-server architecture between Docker server and Docker client. In the server side, normally the Docker daemon, Docker D, must be run, and the Docker client can use command line interface, the command Docker. So between this Docker server and Docker client, they can communicate each other using this REST API. API means the interface. Now let's check Docker components in detail. So Docker daemon, Docker client, Docker registries, and Docker object. Using these Docker components, we can manage all Docker functions. I already explained Docker daemon is Docker D listens for Docker API request from the client in Docker host with the called Docker server. And this Docker daemon manages Docker objects such as like images, containers, networks, and Docker volumes. And this Docker daemon can communicate with other daemons to manage Docker services. There are many kinds of Docker services. In this case, we need to manage Docker daemon. Docker client, normally client use the command Docker is primary way that many Docker users interact with Docker service. If we use this kind of command like Docker run, client send this command to Docker D in server side. This Docker command by Docker client use Docker API, and Docker client can communicate with more than one daemon using this Docker API. In case of Docker client, I already explained in the previous page, Docker client can use some commands like Docker build, Docker pull, Docker run, and Docker push. Docker build means to create our own images. Docker pull means I want to download images from Docker registry or hub. Docker run start Docker containers with images to use applications. If we want to use these applications, always we have to start Docker containers with these images. If we want to upload our own Docker images, then we can use this command Docker push. Docker registry. This one stores Docker images. This one is a kind of public registry that anyone can use with Docker Cloud. This Docker registry or hub can even run your own private registry as well. And when we use this kind of registry, especially two commands, Docker pull and Docker push. If we use the command Docker pull, then we can download the required image from this Docker registry. If we use Docker push, then our images will be uploaded to our registry. Docker stores allow you to buy and sell Docker images or distribute them for free. I already explained we can create our own Docker images. Using this Docker images can be sold in Docker registry or distribute for free for the users. Also, Docker registry can upgrade our applications by pulling the new versions of the images and redeploying these containers. So if we check the Docker registry structure here, the user side or client side can build image and after that push this image to Docker registry. Push means upload this images. So the other users anytime can download this image from Docker images and use in client side as well. So if you want to check this Docker registry hub, this website will provide the Docker registry for you. So this is a website for Docker registry, hub.docker.com. So in my case, I will log into my Docker registry. Here, I can create my own Docker registry for myself. So here, enter name or some the descriptions, full descriptions, and visibility means is public or can be the private as well. Also, you can explore the registries. So there are so many the images we can download from the Docker images, like Nginx or Ubuntu, Mongo, MySQL. There are so many. So later in second video, I will explain how to use this kind of Docker repositories. And number 4, Docker object. When we use Docker, we can create and using this Docker object like images, containers, networks, volumes, blocks, and the others. We normally call this kind of things as a Docker object. So let's check one by one as a Docker object. Okay, let's check Docker object one by one. First is Docker images. Docker images are read-only template with instructions for creating a Docker container. If we want to use Docker containers first, we need to create Docker images first. And this image is based on another image with some additional customizations. In this case, normally we call the parent image. And you might create your own images or you might only use those created by others and published in the Docker registry. I already show you this registry website. If you want to build your own images, then we need to create Docker file with a simple syntax for defining the steps needed to create the image and run it. In Docker file, each instructions create a layer in the image. Each image has their own layers. Later I will show you. When you change the Docker file and rebuild the image, only those layers which have changed are rebuilt. Docker images, we have to understand the meaning of the layer. So each image can stack one by one. Normally we call this one a Docker layer. This is part of what makes images so lightweight. Anytime we can stack this image one by one. Also, if we don't need anytime, we can delete this kind of images. So we can say this one so lightweight and small and fast compared to the other virtualization technologies like a virtual machine. Let's check Docker image build. Here, using Docker file, we can build these Docker images, and these images will be saved in Docker instance. And after that, these images can be uploaded to Docker registry, the command Docker push. Also, if we need any kinds of Docker images, then anytime we can download from Docker registries using Docker full command. And if we want to run these images, then we can start these containers. And these containers also can provide the images using Docker commit command. If we want to save this kind of image to database anytime save, we also load this Docker image from database. Docker container. In previous page, I already explained the Docker images. If we want to use this kind of image, we need the Docker container. So Docker container is runnable instance of the image. Also, I already explained the Docker engine. Docker client can access Docker server using API or the CLI. Using this CLI, client can use this CLI to create, start, stop, move, or delete this container. User can connect to one or more networks and attach the storage and even create new images based on its current state. I already explained about this one. The container is relatively well isolated from other containers and is a host machine as well. It is possible to control how isolated containers, network, storage, or other underlying subsystems from other containers or from the host machine as well. So we can say container is defined by its images as well as any configuration options you provide to it when you create or start it. Maybe sometimes we need to remove this kind of the container, and any containers to each state that are not stored in persistent storage will be disappear. So this is Docker container. I already explained about Docker container in previous page. So each Docker container has applications and binaries or libraries. We can say this is a kind of the images, and this container can be run in Docker engine. Also, each containers can be isolated to each other. Here, we can find the Docker container concept, the kernel. So let's check the one by one of Docker container. In case of the Linux operating system, consists of the two parts, booting file system and root file systems. And the root file system means it's a kind of directory in Linux like a bin, etc, or USR, etc. as well. Booting file system consists of two parts such as boot, loader, and kernel. So here the kernel as a booting file system. We can add these base images like a Debian, and also we can add more images like Emacs and Apache, etc. as well. And each of these image layers only the read-only layer. So we cannot write or change some data inside the image. In this case, we need the containers. Each image has their own the parent image, but the base image does not have any the parent image. So in case of users, if they want to use this kind of images or the write or change some data, then only we have to use, the users must use only the containers. Only through the containers user can access these images. Okay, Docker services. Docker services, using Docker service, we can scale the containers across multiple Docker daemons. Docker daemon means it's a server side, it's working, it's running in server side. If we use the Docker services, then these will work together as a swarm with multiple managers and workers. About Docker Swarm, the next page I will explain about this one. Using these Docker services, we can define the desired state, such as the number of the replications from the service, and this kind of services must be available at any given time. This service is by default load balances across all worker nodes. Worker nodes can be used in Docker Swarm. However, Docker services consist of some Docker managers and workers, but to the consumer or client, only Docker Swarm service appears to be a single application. So far, I explained the Docker concept and Docker components and Docker architects as well. So the last part will be Docker Triad. As a Docker Triad, I can suggest Docker Machine, Swarm, and Compose. So here, this kind of things is a kind of extension of Docker functions. Using this kind of Docker Triad, we can use Docker abundant besides Docker basic functions. So let's check one by one. So first, Docker Machine. So Docker Machine is a tool to let you install Docker engine on virtual host and manage the host with Docker Machine command. Docker Machine is just a command, but if we use Docker command, we can install Docker engine on virtual host, manage the other host as well. So I already explained. So using Docker Machine, we can create a Docker host on your local Mac, Windows box, or your company networks in the data center, or cloud providers like Azure, AWS, or DigitalOcean. If we use this Docker Machine command, we can start, inspect, stop, and restart the managed host. Also, it is possible to upgrade Docker client, daemon, and configure Docker client to talk to your host. This is a Docker original host, Docker server, Docker client to use the command the Docker, and this is a Docker machine. So using Docker machine, we can create another host with Docker server and REST API. If we run this kind of images, and after that, we can create this kind of Docker host here, number 1, number 2, number 3 host. And after that, we can run the images on all Docker hosts. This is a kind of example how to use the Docker machine. For example, the command Docker machine, and after that, create. And as a driver, we can choose the Virtualization and the name of the host, 1, 2, 3, like this. Only this Docker machine, we can create many Docker hosts. So, and after that, we can check the created Docker host using this command, Docker machine ls. Then here, we can find Docker machine with IP address and port numbers each other. Second is Docker Swarm. Docker Swarm is a group of machines to consist of the cluster, and each machine must have the running Docker system. If we create this kind of the cluster, we can run Docker commands, but now they execute on the cluster by Docker Swarm Manager. So in the swarm, each machine can be physical or can be virtual machines. If these machines join the swarm, they are referred to as a node. In Docker Swarm, there are 3 components. First, Docker client to access these Docker daemons. But this request from Docker client first will be transferred to Docker Swarm managers. And after that, Docker Swarm will choose available worker node to transfer this request from Docker client. And after that, Docker worker node will perform this request from Docker client. And each Docker worker node has the containers and Docker daemon. So this is a Docker system. The last is Docker Compose. Docker Compose is a kind of tool for defining and running multi-container Docker applications. When we use this Compose, always we have to use the YAML file to configure our application service. In Docker Compose, we can use only the single command to create and start all the services from our configuration. So Docker Compose can work in all environments like production, staging, development, testing, as well as CI workflows. When we use this kind of Docker Compose, there are 3-step process. First, we need to define our application's environment using Docker file. Then it can be reproduced anywhere. Second, we need to define the services to make up our applications, especially this one, Docker Compose YAML file. And these services can be run together in isolated environment. The third step is to run Docker Compose up. Then Compose will start and run our all applications. So this is an example of Docker Compose. So here there are many containers. If we use the Docker YAML file by the Docker Compose, then we can start many Docker containers at the same time. And each this YAML file has their own syntax, but this syntax not so complicated. It's very easy to run. Summary. In this video, I introduce the Docker system. So at first, the Docker concept as a container system, and after that, what is different between virtual machine and Docker containers, and after that, I introduced Docker components like Docker engine, architecture, and the last topic was Docker object and Docker tools, especially 3 main tools we can extend Docker functions. And the next video, I will explain how to install Docker system on Linux system. And after that, I will explain how to use the basic Docker commands. And after that, I will show you how to use Docker images and Docker containers. The last main topic will be how to manage Docker daemons. Thank you for watching this video, and goodbye.